Topic 1, Day 1, Rounding and Significant Figures. Hopefully this first part is a reminder of our decimal place value chart. But if we think about this decimal point here, and then numbers that are getting larger than ones, we have our ones, tens, hundred, thousands, and so on. And then into our decimals, we have our tenths place, our hundredths place, our thousandths place, so on and so forth. When we're looking to round a number, we first have to identify which place value we want to round to. All right, so figure out what number that is, and then look at the digit that's immediately right of the desired digit. If that number that you're looking at is 5 or greater, you're going to round up. 4 or less, you're going to round down. So let's take a look at this first teacher example. Round the number 14.03758 to the hundredths place. So our hundredths place is 2 decimal places after our decimal point. So here that 3 is our hundredths place, which means we have to look at the 7. And since 7 is greater than 5, that means our 3 needs to get rounded up, and then all the numbers after that we don't care about. So let's get 14.04. And again, it's 4 because 7 is greater than 5. For the second part, we need to put this fraction into the calculator, right? So 3 plus the square root of 5, all divided by the square root of 2. And when I put that in the calculator, I get 3.702459 and a couple more digits after that. And this one is asking for 3 decimal places. So 3 is our first decimal place, 7 is our second, 0 is our third, and we're going to use the same rules. So let's start by identifying 0 is the place value we're looking at, and then 2 is the one immediately right of it. 2 is less than 5, which means we're going to keep it the same or round down. So it'll be 3.70. And those are our 2 answers. So go ahead and try student example number 1. When we talk about the term significant figures, we're identifying the extent to which the accuracy we're using when we measure some amount, right? So if we take measuring instruments like thermometers or scales or rulers, they're limited in how much the number of digits that they can measure to, or the resolution. And that determines the number of significant figures. Let's take it, for example, we have a tape measure, and we want to measure how tall somebody is, right? So most commonly we'll say like 5 feet and 5 inches maybe. And sometimes if you're being, you want to be a little bit more specific, you're saying 5 feet and 5.5 inches, right? But if somebody says 5.521783210 inches, you're like, well, how do you know all of those numbers, right? You can't look at, a quarter of an inch, a tenth of an inch, thousandths of an inch from a tape measure and get that kind of specificity, right? So it would be inaccurate to say that's actually your height based on the tape measure. There are some rules that we need to abide by when we're going over significant figures. All right, so when you look at a number and it's asking how many significant figures are there, we can figure that out by following these rules. Pretty much, if it is not a 0, the number is significant, okay? If they are leading zeros, so leading zeros are zeros in front of your first non-zero number. So if you look here, 0.0072100, the first 3 zeros are considered leading zeros. They are not significant. Trailing zeros right of a decimal point are significant. So here you can see we have a decimal point, and these zeros are to the right of that decimal point. Those trailing zeros are significant. All right, zeros in between significant digits are significant. and then zeros at the end of whole numbers. If there is a decimal point, significant. If there's not a decimal point, not significant. So for example, if I had the number 300 and I had the decimal point, we would have 3 significant figures. If I just had the number 300 without a decimal point, we have 1 significant figure. Okay, so here are a couple of examples. The number 31.4, all of those digits are non-zero digits, which means all 3 of them are significant. So there are 3 significant figures. The number 0.7, the 0 in front is a leading 0, so it is not significant, and then 7 is our first significant digit, so it has 1 significant figure. 10.06, the zeros are in between, so zeros in between significant digits, 1 and 6, are also significant. So this one has 4 significant digits. And then 0.0098, again, leading zeros are not significant. There are only 2 significant digits here, 9 and 8. Okay. So if we look, the mass of 1 grain of sand was recorded at 0.000604 grams. How many significant digits are there? So these ones are our leading zeros, are not significant. Zeros that are in between are significant. 6 and 4 are not 0, therefore they are significant. So we have 3 significant digits. Try student example number 2. Okay. And then try student example number 3.